Hello, wonderful students of Senior 2. I'm so happy to be with you on this online learning platform, and I hope you are going to enjoy our lessons together. Today, we are going to be looking at a topic called electricity, and the subtopic is direct current, and this is Unit 13, if you remember very well from your textbooks. And Unit 13 talks about arrangement of resistors in an electric circuit. And our lesson title today is comparing total resistance for both a series and parallel circuits. So it means we are going to have two kinds of circuits here. So feel welcome. In our lesson today, we have a few lesson objectives that I hope by the end of this lesson, every one of you will have got something from this lesson. Number one, I want you to be able to connect an electric circuit for both a series as well as parallel arrangements. Number two, I want you to be able to use a voltmeter or a multimeter to measure the potential difference across a given load. I will also be asking you to be able to use an ammeter to measure current through a load. And lastly, which is the main objective actually of this for this experiment, is to be able to compare resistance for series as well as for parallel circuits. So let's go to the experiment and see what we have arranged for this lesson. Our experiment is about comparing resistances of parallel circuits and series circuits. On the table here, you can see we have got a lot of laboratory apparatuses that we use in physics. And I'm very sure you have already been introduced to many of these apparatuses. Let me start with this. This is a dry cell, and we have put the dry cells in cell holders. Each one is carrying one cell. So we have got two cells there. And what I have done, I've already connecting wires to the two terminals of the cell holder. Then, right here, we have got a switch. You can see, this is a switch. A switch is for opening and closing the circuit. We also have these two devices here. They look similar to each other, but they perform different functions. This is an ammeter, which measures what? What? Current. And this is a voltmeter, which measures voltage. Okay, again, I've already connected two wires to each one of them, as you can see. And this is a very special board for bulbs. A bulb can also be called a load, as you remember. So we have how many bulbs here? There are three. And each bulb has got two wires connecting them, as you can see. So we have got three bulbs. We shall be asked to arrange these bulbs in series, also to arrange them in parallel. So that's what we have. If you want, you can remove the bulb from the bulb holder, just like this. You can also fix it back. Okay. So let's delve into the question. Look at the diagram that we have. On the diagram, we have a battery, which we have already talked about, two cells, these ones, which are connected to each other. On the right-hand side, you have got a switch. When you follow this down, you have got an ammeter. And on the left-hand side, you have got a junction that is a bit complicated, junction Y and junction X. In between these junctions, we have three bulbs. We are calling this one B1, this is B2, and this is B3. But they are all bulbs. And then we complete the circuit going back to the battery. So as you remember in our lesson objective, students of Senior 2, you should be able to make a circuit connection. And so we are going to connect this electric circuit together. Let's start. Our starting point should be arranging the equipment on your table the way they appear on our circuit diagram. Look at the circuit diagram one more time. So, on the circuit diagram here, let's begin with the battery. The positive is on the left and negative is on the right. So again, as you can see from our battery, this terminal right here is positive and this one is negative. So we put positive on the left here, okay, and negative is on the right. Then from the battery, we go to the switch. And this is our switch. The switch has two wires. As you can see, this is the red wire and this is the black one, two wires. So from the battery, we go to the switch. Just like here, from the battery, we go to the switch. This is component number 1 and this is component number 2. Let's go to component number 3. Component number 3 down here is the what? The ammeter. That's component number 3. So again, our ammeter should come right here. That's component number 3. Let's go to component number 4. Component number 4, we have 3 bulbs. 3 bulbs. B1, B2, and B3. And so, the 3 bulbs are right here. Remember, each bulb, as we said, has got 2 wires. So this is B1, this is B2, and this is B3. And from the bulbs, we go back to the battery. So we go back to the battery. So after you have arranged your apparatus like this, it becomes very easy for you to complete the circuit. So how do we complete the circuit? Again, let's follow the wires. Let's follow our circuit diagram. From the battery here, we connect it to the switch. So I'm going to get the wire that is coming from the battery and I'm going to connect it to the switch and make a very tight connection like this. Okay, so we are done with that connection. Let's go to the next one, joining the switch to the ammeter. So you have one wire from the ammeter and you have another wire from the switch. But here you have to be very careful. Look at the terminal from the cell. It is negative terminal. If we follow through, it is the black wire that joins the red wire and comes here. So it means that is the negative terminal on this black wire. So the negative terminal has to be joined to the negative terminal, not to the positive. If we join to the positive, you'll see the deflection would happen in the opposite direction, and we don't want to get that. So I'm going to make the connection on the negative terminal of the ammeter. So that is gone. Let's try to follow it again. From the cell, follow the black line, the black wire, which is this one. It goes up to the switch because it joins the red one. Then from the switch, it is this black wire and goes up to the negative terminal of the ammeter, which is this one. Then from the negative terminal of the ammeter, the positive terminal of the ammeter, we are coming to the 3 bulbs. But if you look at these 3 bulbs, how many wires are coming from these 3 bulbs? You see, this is a wire, this is a wire number 2, this is a wire number 3. So it means there are 3 wires. I'm going to pick all the 3 wires coming from this side. There's this wire number 1, then there's this black one, which is wire number 2, and the red wire. I hope you are able to see all these 3 wires coming from the 3 bulbs. Okay? The 3 wires here. You can see 1, 2, 3. These are the 3 wires. I'm going to join it with a wire coming from the ammeter. And the one coming from the ammeter is this one. So I'm going to join them together. So you twist to make it very tight. And so that is what we have. Of course, we have very many wires here, but you know where each one is coming from, right? Okay. Let's go to the left-hand side. Look at the left-hand side here. We also have how many wires? 3 of them. Wire number 1, wire number 2, and wire number 3. And where are they? On our table here. Those 3 wires are here. Okay? Wire number 1, number 2, number 3. So we get these 3 wires. They are here. Okay? And then we join them to the wire which is coming from the what? The battery. The wire coming from the battery is here. We join them like this. Good. Our circuit now is complete. Let's revisit the circuit again one more time. From the negative of the cell, which is here, we come to the switch. Okay, this is our pathway. We come to the switch. Then from the switch, we go to the ammeter. From the ammeter, there are 3 wires leading to the bulbs, and they are here. From the bulb, there are 3 wires here that are leading back to the cell. So our circuit is complete. Right, so we are done with procedure A, this one. Connect the electric circuit as shown in the figure above. We are done with that. Now we go to procedure B. Let's look at what procedure B tells us. Procedure B is telling us to close switch K. Close switch K. Remember, this is our switch K. So we are going to close it. And I want you to observe what happens to our bulbs and also to the ammeter when we close switch K. So I'm going to close it, and I hope you're ready. Great. Look at what happens to our ammeter. Let me first open the switch. When I open the switch, you see what happens to the pointer? Close the switch. You see what happens to the pointer? It means our connection is correct and there's current flowing in the circuit. And that is amazing, right? If you want to become electrical engineers in the future as physics students, you need to be practical and do these kinds of experiments, because that is what you do in real life, electrical engineers, the ones that supply electricity to our homes. So it's a very interesting stuff. Now, I also want you to look at the change that is happening on our bulbs. When the circuit is closed, see what happens. Do you see anything happening to these bulbs? I see nothing. But when I close the switch, look at what happens to the 3 bulbs. They're all giving what? Light. But if you look at those 3 bulbs very well, these 3 bulbs, look at them very well. Are they giving the same amount of light? Look at it very well. Obviously, no. And yet we have connected them to the same supply source. Why? It is because these 3 bulbs are not identical. They are not the same. They are all different. And that's why we want to investigate what happens when you connect identical bulbs and non-identical bulbs. So let's go to procedure number C. which says, read and record the current IP. Now, this small p is referring to current in parallel circuit, flowing through the ammeter. Now, when you look at this, you will remember from your theory lessons that whenever bulbs or loads are connected in such a way that there is a junction, then those bulbs are in parallel. When I talk of a junction, it is this. This is what I mean. The current which is coming from the ammeter comes through this red wire. On reaching this junction, a junction is where these wires are joined together. I think you can see where these wires are joined together. This is the one coming from the ammeter, but it is joining 3 more wires going to the bulbs. This is like a road junction. So when you come to a road junction and there are 3 roads ahead of you, you can choose to use one of them. And that's why we are saying these bulbs are connected in parallel. Why? Because current has got a junction. Current can choose to pass through the first bulb, the second bulb, or the third bulb, because there is a junction. This is the junction we're talking about. So this kind of arrangement is called parallel arrangement. In the next few steps, we shall also look at what we call series arrangement. Okay, so they're telling us here to record the current IP flowing through the ammeter. Again, let's look at our ammeter very well. Our ammeter, we have connected this bulb, this wire, on 1 ampere, meaning that we shall use the upper scale. Not the lower scale, but the upper scale. And from 0 to 0.2, this one is not 2, but it is 0.2. From 0 to 0.2, we have got 10 graduations. So, what does that tell you in simple mathematics? When you have 10 graduations, which is 10x, is equal to 0.2 amperes. When I divide both sides by 10, it means x is equal to 0.02 amperes. So it means each small graduation is 0.02 amperes. So let us read how many graduations our pointer is covering. So let's follow it together. Remember, these are 10 graduations. Actually, we have gone up to 0.4. So we are just getting after 0.4. Look, after 0.4, these are 5, 6, 7, 8. Exactly 8 graduations after 0.4. Check it for yourself. Exactly 8 graduations. I hope you can see. 8 graduations after 0.4. So what am I going to do? I'm going to say it is 0.4 plus. How many graduations? There are 8 of them, but each graduation, remember, stands for 0.02. So I multiply 8 by 0.02. Do some quick math and see. 8 times 0.02. That becomes 0.4 plus 0.16. Have you performed that mathematics? It's very easy. So when you add the 2, we are going to get 0.56. And because this is current, the unit is amperes. Hope you get that. We are not guessing it. We are getting it from our ammeter. So let me record that value, because on this table, we have been provided with a space to record our value. 0.56 ampere. Ampere is already written here. Very good. Right, so you see, we are done with part C, where we have got our current very well, which is IP. Now let's go to part D. Part D says, use the multimeter or voltmeter provided to measure the voltage Vp across all the bulbs. This is very important. All the bulbs. Record your answer to how many decimal places? 1 decimal place. Now, the multimeter is this device here. This is our multimeter. It's more sensitive than the analog voltmeter we have been using here. This one can measure voltage, it can measure current, it can also measure resistance, and indeed, it can also measure temperature. You can see here degrees Celsius, but we are not going into all that. But it is a digital device. As you can see, the readings will be displayed on this LCD screen, so we can just take our readings. And I want you to see this very well, so I'm going to put the backlight. You see, this is a backlight, so it makes it easier for us to be able to see. A multimeter has got 2 terminals. You can see we call them probes. So if we want to take a voltage between 2 points, across any 2 points, we are going to use these probes. We shall use these probes to get the points, so we can take our voltage. So here they're telling us, use the multimeter to measure the voltage Vp across all the bulbs. Let's go to the circuit again. When you look at the circuit, we had 2 junctions. This is the first junction, and then this is the second junction. Okay, you remember that? These are the 2 junctions. So for us to be able to measure the voltage across all the bulbs, we are going to use these 2 junctions and use our probes to get the voltage. So what do? We will get one of the probes from the multimeter and connect it to this. Just make sure the connection is tight. And we are going to do the same thing with the second probe. And that's what I've done. Make sure the connection is tight enough. And so you can see what is happening to our multimeter. Even if I decide to close the switch, open the switch, if I open the switch, you can see the reading here is what? 0.000, and then there's this V at the bottom, volts. When I close the switch, I don't expect the reading to remain at 0. The reading now, okay, let me switch the light on so you can see. It is very sensitive. Even slight vibrations may cause a small change. But it has stabilized at about 1.471. But remember, they're asking us to record our reading to how many decimal places? 1 decimal place. So 1.46 or 1.47 to 1 decimal place becomes 1.5. So it means our Vp, we are going to record it as 1.5 volts. Remember, to 1 decimal place, 4, 6, we get 1 from 6, we add it onto 4, it becomes 5. So that is our reading. I hope we are following that very nicely. This is called a multimeter, which can be used as an ammeter, a voltmeter, or even an ohm meter for measuring resistances. Okay, I'm going to open the switch and continue with other parts of this experiment. So it means we go to part E. Part E says, theory says that all the measured voltages above are equal. Now, the voltage we are talking about is the voltage across each of these 3 cells. Each of these 3 bulbs. Let's try to measure the voltage across each of these 3 bulbs. So I'm going to switch this on, and we shall use our multimeter. We want to get the voltage across B1, voltage across B2, and voltage across B3. Okay, so for B1, we get the voltage, B2 we get the voltage, and B3 we also get the voltage. Let's look at the voltage across B1. So I'm going to put my multimeter here. That is giving me 1.39. I think you can see there, 1.39 volts. To one decimal place is approximately 1.4. So let me record 1.4 volts. I go to the second one. This is giving me 1.397. I hope you can see very well. 1.397. To one decimal place, that becomes 1.4 volts. Then look at the third one across B3. 1.396. 1.397. You see, it is changing but it's ranging around there. 1.39. Again, to one decimal place, it becomes 1.4 volts. So how many bulbs do we have here? We have 1, 2, 3. And how are they connected? In series or in parallel? In the beginning of this lesson, we said they are connected in parallel. So they are telling us the voltages we have measured here across B1, across B2 and B3. Theory says that all these voltages are equal. Do our results, the results we have got here, do they support that suggestion? What should your answer be? Look at this. Voltage across B1, 1.4 volts. Across B2, 1.4 volts. Across B3, 1.4 volts. Does it support? According to me, yes, it supports. So it means I'm going to say here, yes, our results support this theory, and that means we are very accurate. Okay, let's go to part F. Part F, they are saying disconnect the circuit. So we are going to disconnect the circuit and then go to part G, where they want us to arrange the bulbs B1, B2, B3 in series. So we are going to disconnect our circuit and continue. Right, so we are done with part D. We are also done with part E, that involves some reasoning, but reasoning basing on facts that we have got from our experiment. So that leads us to part F. Disconnect the circuit. You can see I've disconnected it. Then part G, arrange the bulbs B1, B2, and B3 in what? In series. That's a very important word there, in series. So when they are in series, it means there is only one wire joining all the three bulbs. Current doesn't have any option. Current must flow through all the three bulbs. That's the meaning of series connection. So this is what I'm going to do. You see, there's this wire coming from the ammeter. In the previous connection, you still remember very well. So I'm going to get one wire from this bulb, then I will connect them like this. Okay? And then from this bulb, remember the current flowing through this bulb must flow through the next bulb without giving junctions. So I'm going to connect this bulb to the next bulb. So if I do that, it means I have to join these two wires. And I think you are seeing how it is moving. From the ammeter to the bulb. From this first bulb, B1, I connect it straight to B2 without giving any junction. And then the wire from B2, I think now you see where we are going, the wire from B2 will now connect to the wire from B3. That's what I've done. And lastly, this wire from B3 then connects to the power supply. Okay? So you can see, this is called series connection. When current flows from here and comes here, it flows through this bulb, then flows through this wire. Let me pick it out for you. Flows through this wire, continues and comes to this bulb, and then flows through this wire and comes to this bulb, and then continues there, and it goes and completes the circuit. So that is a series connection. So that is part G. Part H, record the current flowing through the three bulbs in series. Of course, we can't record current if our circuit is off. Our circuit must be on. So I switch the circuit on. Again, I want you to observe the three bulbs. One of them appears to be giving light, at least you can see. Even this one is giving light, but the amount of light here is more than the amount of light there. Remember previously I told you these three bulbs are not identical. They are non-identical. That's why they are giving different amounts of lights. Okay, so the question is, measure the voltage Vs across all the three bulbs in series. Now, all the three bulbs in series, if I measure the voltage across them, remember the junction starts from here. So the current entering the three bulbs starts from here. Okay, and then after the third bulb, remember the wire from the third bulb is this one. So these are the two junctions I'm interested in. So what am I going to do? I'm going to bring my multimeter and then get the two probes, okay, and then place one probe on one of the terminals and the second one on the other terminal. And check. What is it giving me here? About 2.353. We want to record to only how many decimal places? One decimal place. That becomes 2.4 volts. Okay? Check on the screen. About 2.4 volts. Okay? So I'm going to record that. Vs is 2.4 volts. Here we had 1.5 volts. Calculate. Oh, sorry, that is not volt. Yes, that's voltage. Record the current flowing through the three resistors. I've not recorded the current. We need to record the current. Okay, that was voltage. Again, when you check here, we have connected to 1 ampere, and that means we read the upper scale. Again, when you check the upper scale, these are 5 graduations, 6, 7, between 7 and 8. So that means it is 7.5. So what you do, you get your calculator and say 7.5 times 0.02. So when you multiply that, you get 0.15. So our current IS is 0.15 amperes. Calculate the resistances Rp and Rs using these equations. We have two equations here. So let's start with Rp. Rp is Vp. Now we go up and look for Vp. Vp is here, which is 1.5 volts, volts, divided by Ip. And Ip is 0.56 amperes. So let's press that and see what we get. 1.5 divided by 0.56. We are getting 2.678. To 2 decimal places, it becomes 2.7. And remember this resistance, so that becomes ohms. So let's look at Rs. Rs, from our formula, is given as Vs over Is. Again, we look for Vs. Vs is given as 2.4 volts divided by Is. And Is, we have got it as 0.15 amperes. Again, we press our calculator. That is 2.4 divided by 0.15. Let's see what we get. We are getting 16 ohms. We are getting 16 ohms. Remember this point from your theory lessons, very important. When you connect resistors in series and in parallel, they don't have the same value. When you connect resistors in series, the total value or total resistance is very high. When resistors are in parallel, the total or effective value of resistance is very low. Look at our figures. Rp, which is the total resistance for those resistors in parallel, is 2.7 ohms only. But for series, it is how many ohms? 16 ohms. And that proves that point we had in the theory. So thank you so much, my wonderful students who have been attending this learning platform online. That today we have learned how to make connections of electric circuit. We have also learned the use of a voltmeter and an ammeter, and also a multimeter. I hope you remember the digital meter that we are using for measuring, a voltmeter. We have also learned how to connect resistors in series and also in parallel. And most importantly, how to determine the effective resistance for resistors in series and in parallel practically, not theoretically, but practically. Thank you so much for attending this lesson. I hope you have learned a lot of concepts. I'll join you in the next session. Thank you.